Okay, Adam's only got an hour today because of the time difference, so I suggest we get straight into it. All right, so we're going to talk today about GPT-4. I guess I thought I might start off by giving a brief recap of how we got to here, just taking a few minutes to talk about GPT-1, GPT-2, GPT-3. So I'm going to put something about that up on the boards. You might take a look at these two pictures that I've got over there and guess what they are. Any immediate guesses?
I'm going to guess GPT-3 and GPT-4.
No, one of them is old. Very old.
It's not the Manhattan Project, is it?
I was going to say the one on the right looks like it might be a 1950s, 60s, 70s sort of data center kind of place. Something like that.
Oh, like the Turing machine, maybe?
Okay, keep thinking about it. I'll tell you in a minute. Okay, so here's a recap of not that, which is kind of history, or the thing on the right is history. The thing on the left is future. But here's a bit of recent history. So GPT-1 was basically ignored by everybody and derided by the deep learning community as being boring and containing nothing new. It's just a transformer. We know what those are. All you did was kind of train one that looks big. These days it's hilarious that it's not even written in millions, of course, right? So now you write the number of parameters in billions. At the time, whoa, that was a huge model. And it was trained on a huge data set, which was 4.5 gigabytes. So this was of text from books and so on. That was in 2018. GPT-2 was 1.5 billion parameters. Maybe I'll put some headings here. This is parameters. This is training set. And that's self-explanatory. So this was trained on a bigger corpus of about 40 gigabytes of text scraped from the internet. There was a bit more attention to GPT-2. Sort of the headline, each of these sort of came with an idea of what the developers thought was novel about it. And GPT-2 was hailed as novel because it was a multitask model. And that was the idea that, and to quote from the paper, single task training on a single domain dataset is a major contributor to the lack of generalization. And the idea here was to train simultaneously on many different tasks by training on a very wide dataset in an unsupervised fashion. At the time, that was fairly novel. At least the scale was novel. I think GPT-3 was the first time...
Yeah. Sorry about the background noise. Before moving on to GPT-3, I remember about GPT-2 because when this happened, I was taking the natural language processing class in my master's, and I remember the lecturer, who's a prominent researcher in the field, said, well, because they didn't release the source code or something like that. They kind of described the technique, but they were a little bit coy about the details or something. I can't remember exactly what happened. And my lecturer was saying that's a bit silly because they're not doing anything that new, and it's not that it's that much of an advance over state of the art. But at the time, obviously, OpenAI was like at least being cautious about that kind of thing, I guess.
Yeah, for maybe reasons that have changed over the years. I guess the justification used to be, well, has always been partly safety, I guess, but I think there were GPT-2, I don't remember there being any details really mysterious. Do you remember what exactly that was?
I don't remember.
Yeah.
Okay. Seeing you sketch it out here like this makes me imagine a frontier, a three-dimensional frontier, expanding frontier, where the three dimensions are the dimensions along which you can have scaling. I suppose we talked about this in the past, and maybe it's really only the two, but basically you have the what is it? The size of the model, the training size of the training set, and the compute that go into it. If I'm remembering correctly, those are sort of the three elements. Maybe I'm wrong about that. That are subject to this the quote unquote scaling laws. Is that correct? Sorry, I may have those details incorrect. But what I think would be really interesting to see is something analogous to the two-dimensional. Like we could do it in 3 dimensions, but maybe 2 would be enough. But I've seen very useful infographics, so charts that have sort of a trajectory. Sometimes it'll be logarithmic, to visually represent in a linear visualization of a nonlinear phenomena, and then stacked on that the curve are key benchmarks or thresholds or milestones along the way, things that were achieved. And I've seen this for a whole variety of things, lots of different processes, lots of different phenomena. The one that's in my mind that I'm thinking prominently of is evolution and biological complexity and the points at which new capabilities and features emerged in evolutionary space, not necessarily in evolutionary time, but just in space in terms of the complexity. And I'm wondering, it would be really neat to see a sort of a visual summary of the emergent capability that manifest in these systems as they got bigger and as they scaled according to this laws. It would be I think that would be a very useful tool for everybody, including the general public, to kind of get a sense of okay, well, where have we come as we've gone through these iterations? And I don't necessarily just mean the GPT specifically. Yeah. I mean, there are many other transformer-based models, to my knowledge, and it would be neat to see sort of as many as possible all visualized together and with some sort of visual summary communicating the scales at which certain capabilities begin to emerge. I think that'd be really, really useful. If the data were available, I could certainly get my team to help put that visualization together, and maybe that would be something worth publishing.
Yeah, I've seen visualizations of sizes of models and so on, but they tend to be kind of insider baseball a little bit because it's not, when you look at those graphs, you kind of have to be pretty familiar with many, many different pieces of work in the literature to understand how those numbers translate into capabilities, which is as I've repeated in the past, there's like a 1-2 punch to understand our current era. One is scaling laws, but the scaling laws refer to, as you say, like compute, model size, and dataset size. And those aren't very visceral quantities. And the loss, which is the quantity that decreases with a power law, it's sort of a very esoteric thing, right? It's just the accuracy on predicting the next token, which doesn't obviously correlate with things we care about. And that's the left punch, and the right punch is the translation of those power laws, scaling laws, into capabilities. And that's what we sort of see emerge in each generation, and that's what's in the blue here, right? So somehow at each level of scale, sort of unexpected things happen, hard to predict in advance. For example, GPT-2 suddenly starts to have something that looks like multitask learning or positive transfer between different tasks. It benefits in one area from things it's learned in another area, and then that continues with GPT-3 and GPT-4. But yeah, I think that kind of infographic, if it could tie those things together in a way that made it easy to apprehend, could do a lot for people who probably are more or less at this point just kind of noticing the latest thing and not really seeing it as part of a trajectory, which is the thing that really drives home where we're going, I would say. All right, so GPT-3, 175 billion parameters, was trained on a corpus containing many different things, internet text, basically, 570 gigabytes, so that was in 2020. And the title of the paper was Language Models Are Few-Shot Learners. And so the kind of key emergent capability at this scale was in context learning would be one way of saying it. So roughly speaking, without changing the parameters of the model, just by giving it some information in the context, you can basically have the model act as though it has learned something, so it can modify its behavior and its understanding in a fairly sophisticated way based on sort of at runtime. This was also the first time where the scaling laws were clarified. So in 2020 there was earlier literature before that, but not really in the context of this series of transformer models at many different scales. So scaling laws was the other big thing from this generation. Anybody want to comment on GPT-3 before I move on to GPT-4? Okay, we do know the date.
Well, just one very quick comment is that it seems like GPT-3 spent quite a while in this kind of stealth mode. Was there a period in which its potential was not recognized or understood, or not promoted? Was this sort of an active, not obfuscation, but just a hesitancy to completely disclose and deploy the technology for whatever reasons, proprietary purposes, trying to capitalize on it, trying to profit from it, trying to get alignment, or not in the AGI sense, but in the avoiding certain pitfalls and making it useful. I mean, what was going on? Why the big gap between 2020 when it first emerged and sort of 2022 when the public really got a full taste of GPT-3 and then GPT 3.5 with ChatGPT? Was there something going on there that we might be concerned or expect would happen again and give us sort of a winter between the current and then the next generation? And maybe that's going on right now. I don't know.
I don't think so. I think mostly it was a business model problem rather than a technical problem. My mental model is of Ilya Sutskever and the rest of the scientific team charging along, basically on track, making progress. But the business side of OpenAI didn't really know what to do with GPT-3. Basically, nobody used GPT-3. They released this playground. People did cute things with it. Basically, it went nowhere, right? To my understanding. Now, it was a very powerful model, but it somehow wasn't directly super useful for making chatbots for reasons to do with the existence of GPT 3.5. Now, people could have used it to do many of the things they're doing now, and, well, for example, we were using it a little bit. Now, many of the things that are happening now could have in principle happened with GPT-3, but you would have had to do a fair bit of engineering on top of it in order to make those really robust. So I think a lot of people's experience would have been, this is awesome, you try it a little bit, but then you go to make more systematic use of it, and the downsides and the inconsistencies and the hallucinations and the inability to really steer it mean that at scale, when you're actually putting it in front of customers and not kind of favorably inclined insiders who will look past those flaws, you probably just see it's not ready for prime time. So I think that was kind of the conclusion. I don't think it was to do with safety that there was like a gap between 2020 and InstructGPT or ChatGPT. So the technical development between 3 and 3.5, well, there was probably a few kind of detailed things, but the headline thing was RLHF, learning from human feedback, which led to InstructGPT, which is no longer just training on internet text. There's kind of a secondary training phase where the model is refined to be better at following instructions and more tuned to be a chatbot, which isn't. It's kind of just a miracle that the original GPT-3 can act as a chatbot. It's very clever. It's in context learning again. If you give it prompts that look like chats, it'll be able to recognize that from its training set and play along. But it's not specifically wanting to be a chatbot. It's just a next token predictor. But Instruct GPT with this additional layer of engineering is actually wanting to be a chatbot and to follow instructions and to not spew racist nonsense or whatever. So basically with those guardrails and more of a fine-tuned behavior to be a chatbot, they had this product, ChatGPT, which was kind of what people wanted when they interacted with the GPT-3, and it crossed some threshold to being good enough to put in front of people and have them kind of find it useful, I guess. But I think that was more of a business or social phenomena than a technical one. I don't know if you'd agree with that, Matt.
I haven't been following as closely as you, but it makes sense to me.
Okay. Yeah, all right. So then there's GPT-4. GPT 3.5 is roughly the same kind of sizes. Well, actually, it's significantly smaller. So ChatGPT, I don't think they've publicly released it. People estimate it's kind of maybe from 1/3 to 1/10 the number of parameters. There's kind of something a bit funny where you do this RLHF process and you can get a much smaller model. That's part of why ChatGPT is much cheaper per token than GPT 3.5. A similar process, I think. So nobody knows. Probably the same corpus, I think, roughly. I don't think there's any new emergent behaviors that really are worth noting from the transition to 3 to 3.5. At least I can't think of any. So let's go straight to 4. Nobody knows. Nobody knows. That's kind of one of the most interesting things about GPT-4, which we can get into more, which is the degree to which even the basic research involved is secret. Not just the number of parameters, the training set, but, well, GPT-4, at least one version of it, can handle an 8 times longer context window than GPT 3.5. So you can put 50 pages of text directly into the context for GPT-4 and ask it questions. Nobody knows how that works under the hood. You can see the contributors that there's a contributions part of the GPT-4 page, and you can guess from some of the authors there. I recognize some of their names and what they've done in the past. So we can maybe have some educated guesses for what's going on there, but nobody knows. All right, so maybe some headlines of what GPT-4 is good at. Does that sound like a good thing to do now? Let me put it on the other board, and then we can get into the details a bit more. So headlines.
It managed to follow scaling laws, which I found exciting. I was a bit nervous, like, oh, maybe it'll break it, but it didn't.
Yeah, scaling laws continue. Right. That's an important one. Although the graph is kind of comical. Maybe I'll try and fit it on here just a sec. It's kind of well, the deep learning literature has always been a bit cagey about, like, by normal scientific standards, actually giving the information, but now it's reached a kind of absurd level. Oh no, that's not the one I mean.
Well, that was going to be my question: is if we don't know the specifics of the training set size and the number of parameters and so forth, how are we still completely confident that the scaling is continuing?
Yeah. Or could we work out the parameters from the scaling laws they've given us, maybe?
Yeah. People have attempted to estimate it, but you see, it depends on which scaling law. Like there's enough variations that, well, when you go orders of magnitude up, even small errors in which law can mean very big differences. So I think it's not trivial to work out from the published information. All right, so this is not like the scaling law posts we've sort of seen in the SLT seminar and so on have on the x-axis also compute, and on the y-axis they would have some sort of loss measure, but it would be for the true training objective, which is predicting the next token on the entire training corpus. That is not what this is. This is predicting the next token in the OpenAI codebase itself, which is not part of the training set. So this is kind of interesting in its own right, because this is GPT-4 learning to predict its own guts, right? And okay, they have like one other graph that's a bit similar. So these are downstream tasks, if you like, right? So this is not the true training objective, but you train the model to some number of compute and then you test it on some held out test set. So, and of a very particular kind, right? Okay, but the scaling laws seem to continue to work, and they claim in the sort of supplementary material, there's a white paper, and then there's a system card, and there's the web page itself, and I'm drawing from all three of those. So the interesting thing about this perhaps is that they state that actually their main engineering objective for GPT-4 was to have much more stable training and much more predictable training. So they don't publish any details, so I have no idea what it means really, but they claim that this is the first time they've trained one of these large models in a way that they predicted in advance exactly how well it would do at a given point and had that work out. So somehow their ability to predict the training of these systems, so they claim, is improving with each generation. And that's kind of what this, I barely even call it a graph, it's like some cartoon, but we don't know what the units are on the x-axis, right, for example.
Will they release it, do you think, like later? Did they do that with GPT-3? They were quiet first. Or I think Matt said GPT-2, they were quiet first, and then...
No, I mean, these numbers, like the number of parameters and the training set size, were released at the very beginning. They may leak for GPT-4, but I have a feeling that this is it. We don't find out from now on. I don't know. Okay. There seems to be a secret paper with more information that you can apply to see. So you may see like some people posting online about additional information they claim to have from that. I haven't seen that paper. So that paper may reveal additional details. It may reveal something about the training set. I have a feeling the number of parameters, like... it's no exaggeration now to say that the precise details of the scaling laws, like the number of parameters, or anything that would allow you to infer the number of parameters, is not only a trade secret, but soon to be like national secrets. As strange as that sounds, I think they will strongly protect this information. Because it's key to being able to reproduce the thing, is to know,
Right.
Well, because it determines how many hundreds of millions of dollars you should spend on GPUs, for instance, right?
And I mean, a lot of things too. If you were, I can imagine quite a bit of information you could infer from those specifics. If you wanted to know where a research project was occurring, and you knew how much compute it took, you could narrow down your search according to energy consumption, for example. So if we're talking about national level security and military concerns, the protecting not only the nature of the training, but the location and that sort of thing. All of these things start to become relevant as this entire enterprise shifts into Manhattan Project kind of territory, as we were talking about last week. So it's. Yeah, I think for the most part we should expect more secrecy rather than less going forward, other things being equal, which I suppose is something to be concerned about in itself, especially if alignment and other concerns, equitability and so forth, if they are to continue to be prioritized and openness and transparency are means to those ends, then I think we have some powerful forces working against those interests. We may already be seeing that with this latest iteration of the technology.
Yeah. Okay, so let's quickly go through the headline features. My overall summary would be no surprises. And that is kind of terrifying. Okay, so why no surprises? Well, as we already discussed, the scaling laws, they claim continue to translate into capability. In this case, it means exam performance. That's the kind of thing they have emphasized. The model continues to improve on the hardest of NLP training sets. That's a little bit in the weeds from our point of view, I think, to talk about like what MMLU means. But the really interesting thing, I think, is that there's a shift from kind of dedicated tasks for machine learning algorithms to let's just run these things on real-world exams for people. This depends on the multimodal capability. So multimodal meaning that the model you can inject tokens that represent images into the model. This has been seen in a few other models in recent years, so in and of itself it's not sort of new, but the integration into a system of this scale is certainly new. So you can show GPT-4 exam papers, like the photo of the exam paper, and it will answer. And in many tasks like the SATs, first year university courses, which are for the Australians, so AP is it Advanced Placement, Adam? Is that what it stands for?
That's correct,
right?
Yep.
Yeah, so this is like first year university classes, if I remember correctly. Is that right?
The AP courses, their purpose is that they are translatable into credit in university in the first year. And so if you do AP courses and pass with a satisfactory score, then you are exempted out of university courses, which you automatically receive credit for.
Right. Yeah, so there's some quoted stats about the bar exam. GPT-3 going from 10th percentile, GPT-4 is 90th percentile, SAT math, 90th percentile, AP biology, sort of the top 20th percentile. The top, it's from like the top score anyway, 5, which if I think is like 85 to 100 percentile. It's not true equally across the board. Maybe I'll put up the next graphic.
So it might be a bit in the weeds, sorry, but do we know what image corresponds to in tokens? So you said like is 32k tokens is like 50 pages. What is that in like images?
Oh yeah, well yeah, I don't know how many tokens per image. That's a good question.
I was going to ask perhaps a related question, and it's probably a stupid one, so I apologize. But are we completely confident that these images are not being analyzed and translated or transcribed or otherwise converted with a separate tool prior to being sort of digested by the model itself, or is that what's happening, or is the model interpreting it sort of natively? I'm not completely clear how this multimodality is being achieved. If the images are being, it seems to me it would be different if the images were being rapidly scanned and their text dumped into, a prompt and the prompt fed into the language model. That would be, in my mind, quite different than the model, directly interpreting the image without that layer of translation from a separate tool going on. And so I don't, if that's something that can be explained very quickly, that would be useful to me. If it's not, then don't bother. I can do my own work later.
No, it's not like that. It's kind of more genuine. So images are tokenized basically by taking, there's many ways, but you could imagine, so one method that's been used, we don't know exactly, I think, what's going on inside GPT-4, but the standard method is to take little patches of the image and then just map that to tokens. So you basically kind of discretize chunks of the image. How you tokenize images by making patches or some other process is probably a matter for that would be probably sort of part of the secret sauce, exactly what works well. But you directly translate the images into tokens and then feed that to the model alongside the text. So, for example, that's how Saycan and Palm-E, like these modern robotics projects that integrate language models, the language model is the brain, and it receives tokens that represent text, but also tokens that represent robot arm measurements, state, images from cameras. Everything gets embedded into this common language space via tokens. So it wouldn't be, the image tokens aren't in the same set. Like there's like tokens that stand for parts of words, and there would also be other tokens that stand for parts of images, if that makes sense.
Okay, that does make sense. Yeah, thank you.
Okay. Is it just per pixel? I don't know if it's tokens per pixel. That seems like it would be a lot of tokens, but maybe that's
That's what I thought, but I don't know how to read a picture. Sorry, continue.
Okay, so capability, exam performance, it does better on reasoning tasks. I haven't looked close enough to compare to Minerva, which is this model that was fine-tuned on math questions and seems to do very well, at least on kind of primary school, high school, and early university. Probably GPT-4 might be competitive with Minerva. I'm not sure. So that was the kind of previous high watermark on kind of reasoning, at least mathematical reasoning. The other really interesting thing, at least for me, is what I've written here as autocatalysis. Catalysis. I'm maybe not quite sure how to pronounce that. So what I mean by this is the model itself being used to train the model. This comes up in a few different ways, and it's not really systematic yet. So you can imagine that this will be something that will become much more systematic in GPT-5, which probably is training already. So maybe I'll say briefly what I mean by this. It's probably fits into a discussion of the secret research, so I'll just clear this board. So part of this is not secret. Part of the autocatalysis, I mean. Okay, so here are the things that seem to be secret. So the exact scaling laws that are involved, how they stabilize the training. We know bits and pieces of this. It reminds me very much of the early parts of the Manhattan Project, where kind of people were publishing and not quite sure why nobody else had published this thing, which seemed to be quite like an immediate consequence of other stuff in the literature. Like it was kind of like a mix of something secret and something's not. You could kind of figure out what was going on. Maybe that'll become harder over time. GPU kernels,
Can you define stability quickly there? What do we mean by stability?
Yeah, so if you go and look at, so there was a model called OPT that was released by Meta, Facebook. And this has a public record of how they trained the thing, which is very enlightening. So when you train these very large language models, it's, as much voodoo and black magic as was required in the early days to train any deep learning model. So you have to get the learning rate right, and then the thing crashes, and then you have to restart from some checkpoint, and you have to vary all sorts of hyperparameters, like the training rate and the parameters in the layer normalization, and like there's many magic numbers in these systems, and if you get them wrong, you'll fall off the scaling law. So as far as I understand it, modern large-scale deep learning training is guided by the scaling laws, and you kind of know how well it should go. And then if you deviate from that, you know you've done something wrong. So then you kind of look at your system and you're kind of like, okay, well, this isn't quite working, but what isn't working? And the stability, what they say in the paper is that, well, it's very brief. It's like one sentence. They're referring to, I think, that a lot of this voodoo seems to have been banished by better engineering. Part of that we understand. I'm looking into this at the moment, but there's a technique for transferring optimal hyperparameters from smaller models to larger ones. I don't know how much of a role that played in GPT-3, but it seems to be involved in a significant way in GPT-4, where, well, there's just better engineering around all this nonsense that you had to do in previous generations, and maybe we're just getting to a more industrial kind of quality of understanding of how to produce these objects. GPU kernels, that's just how you, I mean, there's a whole distributed computing aspect to this, right, which is quite serious. I don't have a good judgment about how much of that is secret and how much of that is public. The long context research, as I already mentioned, is kind of one of the most striking things about GPT-4, and we'll have to see how well it works and how dramatically it changes the game. But in principle, it's a huge deal, right? In principle, this is like bye-bye consultant.
Is it possible that this is using something like the method that you were using before, Dan?
No. No,
so this is full, not a hack or a sneaky workaround.
I don't think this is a cheat. Of course, we don't know. It could be, but I doubt. I mean, it would be so embarrassing if they promoted this 32K context thing, and behind the scenes it was just some kind of pseudo cheat. Now,
I see. Okay.
It's probably not as simple as just the same architecture as a normal transformer, just with a bigger context, and then there's some kind of workaround for making that actually function. I mean, the it's like an ON squared kind of thing. So going from 4,000 to 32,000, a GPU's memory just will not handle that. So it can't be like the most naive direct thing, but you can imagine various things more central to the model. I mean, I could think of 2 or 3 ways to do it. It's probably not super sophisticated, so it probably is one of the 3 things I can think of. But they just made it work. So I think it's real. I don't know if it's equally attentive to every part of that context so that it kind of is as smart on all those 50 pages as it is on the first 5 or whatever. But I would bet on it probably being, like a serious deal. Which is, I mean, if it can attend to 50 pages as well as GPT 3.5 can attend to 1 or 2, that's something.
Yeah.
The costs will come out of like training to 50 pages versus 5 pages, and then you should be able to infer something about the computational complexity of the
That's
method.
true. Yeah.
By whether or not that's 10 times more expensive or 100 times more expensive.
It's only twice as expensive as 8,000 tokens per token. So it's, whatever they're doing, it's not that you just scale up linearly from what it costs for the 8,000 token thing, but it's only twice as much. Yeah, as I've put there, like it's so 12 cents per 1,000 tokens for the 32K context version. It's worth noting that GPT-4 itself is 6 cents per 1,000 token, if I remember correctly, which is 3 times what GPT-3 costs and 30 times what ChatGPT costs. So people talking about integrations of GPT-4, I really have trouble seeing how that's going to be economic for many of the applications. So maybe that's a good thing to talk about next.
One thing I would just observe here is that price isn't cost, and it usually depends on the incentives. So when we look at the difference between price and cost in the disruptive technologies that we've seen in the new industries, the general lesson that we've extracted from looking at the various examples is that it's all about it's determined by the incentives of the individual enterprise or the industry that's involved. There are a lot of exceptions. There are a lot of quirks that can lead to really quite stark distortions between price and cost. In a perfectly efficient and perfectly competitive market, cost and price would correlate very, very closely. So as you can imagine, in industries that either suffer from market inefficiencies or failure outright, and so energy is an industry where that's the case because there are a lot of utilities that are effective monopolies, whether they're state or quasi-government or private. And there can be a huge disconnect between cost and price there. I don't know if it's the same here, but you can easily imagine that this pricing strategy does not reflect particularly accurately the underlying cost structure. So just keep that in mind. And I think there's evidence. I mean, if they can drop the price by a factor of 10 for an older model, that's a pretty good sign that price and cost don't correlate well enough to draw many conclusions from it.
Yeah, I'm just now noting that I talked about the secret research, but didn't come back to the autocatalytic idea. Okay, so autocatalysis refers to catalysis of a reaction by one of its products, right? So here GPT-4 is the product. Where is it being used and where might it be used in the development of its own model and future models? So it's a bit sort of in the details, and maybe we don't have time to talk about it this time, but the final training, there was an additional training stage beyond RLHF in GPT-4, which was, I think it's RBRM, is it? I'll just check.
Do I have access to GPT-4 through ChatGPT at this stage, or see?
Yeah. Adam and I have both played with it. I think it's sort of a staged rollout, but if you're paying for ChatGPT Plus, you probably will get it soon. I actually put myself on the wait list for it to try it out with the bots here. I got accepted into the wait list, but it doesn't work at the moment, so I don't know why. Okay, so there's a final stage, RBRM, where they use GPT-4 itself to predict whether the trained model is following some sort of guidelines or not, and use that signal to refine its training. So that's an interesting development. The kind of big picture there is, the model is able to, well, just like with people, by reflecting on your own speech and thoughts, you can sometimes see that they're inconsistent with your intentions or values or the instructions that you've been given, in a way that, if you were like a perfectly rational being with omniscient cognition, you might be able to make every utterance consistent with all your intentions and all your instructions. But somehow we don't quite work that way, so it can be useful to reflect on the outputs that you give and guide them back into line with what you think your output should be, or what you've been told your output should be. And that's part of the training process now, in a way that it wasn't in the previous generation. So there was RLHF involves training another model, and to some extent it involves GPT-3 itself, but in a much less thoroughgoing way. So that's the present. Putting GPU kernels up here, well, GPT-4 writes code very well. I don't know if they used it to write the kernels, but they will at some point. Intel is already using AI systems, I don't know if it's language models, to lay out chips, as is Google. I think it's highly likely GPT-3 is being used to produce the code for GPT-4 at various levels, including the kernels, and that would continue to become more prevalent, I would think. I don't know about some of these other aspects, but I think that's going to be something you would expect to emerge over the next couple of years, is much more integration of these tools into the production of the next generation. Any questions or comments about that? Okay, just some of the announced integrations and collaborations. I think that's another interesting difference with this generation, right? Partly this is the marketing skill of OpenAI, which has left Google looking completely stupid over the last few months. Despite all the chaos from the Bing Sydney debacle, Microsoft somehow comes out of this looking smart, or at least people seem to think so. They seem to me like stupid sock puppets of OpenAI to some extent, and just deep pockets. But I guess the public probably thinks of them as looking innovative. I don't know. And here are some of the announced collaborations between OpenAI and other companies. Bain is a big consultant company. That's quite interesting to read both the Morgan Stanley and Bain press releases. You get the impression that probably it's mostly bullshit, but the kind of bullshit that becomes true eventually. So they're talking about how they're using OpenAI's tools to examine their huge libraries of PDFs, all sorts of knowledge, and to surface that in a way that can be acted on by analysts through chatbots, through the kind of techniques we've talked about that are being used in many places, including here, where you use embeddings and then you query embeddings and you bring those into the context of a model. But with the larger context for the GPT-4 model, you can do this for real somehow, in a way that querying little chunks of a book and then bringing them into context is kind of faking it, and it fakes it well enough for many purposes. But if you're actually trying to really do a deep analysis on a body of text, I think you can't really beat the genuinely longer context. Salesforce, Slack is integrating ChatGPT. Khan Academy is going to release, has not yet released, but has demoed a kind of tutor bot. Again, with both that and the Duolingo bots, I feel like probably when you use it for the first time, you'll be impressed the first two things you try, and then you'll kind of feel that it's a bit of a pain and probably doesn't quite work very well. And then over the next 2 to 5 years, it'll just get amazing. And I don't know if you saw it, but on the GPT-4 webpage, there was a Socratic dialogue, I think they called it, where the model was queried. There was some kind of high school math problem. The person interacting with it got it wrong and then needed to be guided to getting the answer correct, and all that kind of worked, and the model was doing pretty well in understanding what the problem was, how to diagnose it, what the true answer was, and how to get to that true answer. So that's a kind of artifact of its improvement in performance on exams, right? Is that it seems to understand sufficiently well why it gets the right answer to be able to explain it and to guide someone else in reaching the right answer.
It's interesting. This is perhaps a false reasoning by analogy, but in the case of humans, I think we're probably all familiar with that idea, especially in an any academic setting, where there are various levels of competence up through expertise and mastery, and up at the higher levels of expertise and mastery is you start seeing an emergent ability to translate the understanding of richness and complexity and detail into elegant explanations that really do help convey understanding to those who are less competent. So basically, teachers that are really knowledgeable and knowledgeable experts are able to teach very well because they know the material backwards and forwards and can see it from every angle and understand it from every angle, every nuance. And so this is, and then the flip side of that is that there's also the sort of timeless wisdom that if you really want to learn how to do something, you need to get good at teaching it, and that people who teach become that's a path to sort of very, very high level mastery. And this is an ancient idea, and apprenticeship and mastery is nothing new. It's ancient, and so again, I may be guilty of reasoning by analogy here, but every step along the way, of this sort of journey as these systems are emerging as these systems are demonstrating emergent capability, I am struck personally, and just anecdotally, by how eerily similar it is to the way that humans reason, the way humans learn, the way that humans teach, the way that humans self-reflect now and potentially improve. Now, obviously, there's risk of anthropomorphizing here and all of the rest of that. I'm trying to be vigilant, but the similarities are striking and unnerving to me. I don't know if everybody's having that experience, but it isn't just one thing. It's one thing after the next. So
yeah, I remain uncertain how much of that is just due to the training set, right? It is, after all, trained on a huge amount of our digital exhaust, so behaving in a human-like way is not... It's hard to disentangle what is just emulation and what is kind of a universal phenomena that you would expect, even if it had been trained on like raw experience in the world with no exposure to our way of doing things. I think,
but humans themselves are not trained that way.
That's true.
There are even a handful of examples, and there's plenty of fiction about humans that have grown up in the wild as feral humans. And the feral mind does not possess. I think there are a few very tragic examples. Doesn't possess any of the, not any, but it's grossly deficient in many things that adults that are enculturated and trained and educated by other humans take for granted. So while some raw and latent intelligence is there and gets developed in feral humans, we are ourselves more or less entirely dependent on the enculturation process of our education. And so we're learning from all of that digital exhaust as well. It's not... So maybe it's a good thing that these machines are too. Feral AI. There's a new grunge band name for you.
Yeah, I think that's the kind we don't want. Hallucinations have also decreased. Partly through effort and partly through scale. So that's another interesting... Yeah, I mean, one thing that's worth noting every generation is just how in the previous generation people were very quick to say, oh, this is a fundamental flaw in this whole approach, and this is why it's never going to work and why this is the end of the line. And then the thing varies, but in the next generation, these problems don't always go away, but they tend to be ameliorated in a way that suggests that it's not a fundamental critique. I think we all know of articles that are talking about these kinds of things, even sometimes publishing counterexamples that you can just feed into today's model and see that it handles them perfectly well. And you can see some digs at these... some of the examples that they choose, of common sense reasoning about images, direct digs at people's prophecies about this never being something that a model could do. At this point, it's just kind of, you show GPT-4 an image of a real-world situation, it's going to make sensible predictions about common sense physics and such things, to some degree. Actually, that has implications for self-driving cars, Adam, right? So... You can't put GPT-4 inside a car, but its capability of common sense reasoning... GM is planning on doing it. Oh, yeah, really? I
was going to ask you to add that to your list. They're not necessarily integrated with the self-driving, although there's some movement on that front with integrating LLMs into the actual software stack for the driving itself. But GM is talking about using GPT to basically turn your car into Knight Rider, which is what everybody's always wanted since we were little kids. So we're nearly there, right? It's not too different from the idea we talked about, Dan, about bringing your stuffed animals to life with GPT-4, and a simple, audio in and out device. But yeah, the GM announced a partnership. Is to my understanding, or maybe that I might have insider news there, and it hasn't made the formal announcement yet. But apparently, this is coming. It will effectively be a GPT-4 or further based personal assistant in your vehicle, which is Kit from Knight Rider.
Interesting.
Apart from the self-driving part, that'll be separate. And then when you have both of that, you literally will have Knight Rider.
Yeah, maybe like it's kind of. I don't know if you're watching the bots. The bots have kind of gone stupid today, and I know exactly why. It's because I changed the number of thoughts that they have that they're caching in their context has been increased from 8 to 15, and that has had an unanticipated effect of making them emulate each other. So they're both basically behaving as a kind of mixture of Triku and Doctor, because they can't actually tell their own identity anymore because their identity text has become a smaller percentage of their context. Okay, so this is an example of how fragile the current systems are. Even ChatGPT, right? It's very good at following instructions relative to previous models, but it's still fragile, right? It's got very strict instructions. For example, Triku is supposed to never speak outside of haiku, and it knows what a haiku is, and so on. But it's clearly breaking those instructions because that instruction text is just one of the 15 things in its context, and some of them are quite long, passages from books or whatever, and it just kind of forgot who it is by the time it processes that context. So these things aren't magic, right? And they're still very flawed. So it's worth keeping that in mind. We're not at AGI yet or anything really that close to it. But these fragilities improve, right? So I would expect GPT-4, if I run it, would probably just handle this. Just like, the previous Curie and the sort of editions in between GPT-2 and 3, which you can access through the API, they just can't follow these instructions at all. GPT-3 can, but still has limits. GPT-4, if I get to try it, I expect to just do better automatically at some cost. It's unless you're really in the weeds with trying out these technologies, it's hard to see exactly where the hype finishes and where the progress lies and where the limits currently are. And that's one of the key reasons that I'm messing around with these things. I partly think chatbots are kind of cool and in some sense the future of education, or at least a part of it, a big part. But partly I just want to know what I'm talking about, and being actually, with my hands dirty is the way to do that. Yes, that's just a word on where the limits are right now.
I had fun playing with ChatGPT based on the GPT-4 model earlier today for maybe a better part of an hour. So I have just a few minutes left, but I'd love to share some of that experience. I don't know how profound or useful the insights are, but if we have a couple minutes, it might be helpful. The first thing was that it's noticeably improved. There's no question. I found it improved in every respect in the interactions that I had, and I did not test any of the multimodality at all. I didn't do images or anything like that. This was purely text, and I've been using it to do writing and improve writing quality. I've been using it to help do a little bit of simple Python code stuff for my work, where I have to interact with some of the code that our team is producing. And because of the time differences, in my mornings, I can't call people in certain parts of the world and just get the answers from the software engineers. But ChatGPT has been useful because sometimes it can tell me what's going on or whatever. And ChatGPT, based on the GPT-4, is a big step of improvement in all of those respects. It writes better, it reasons better, it thinks better, it answers questions better. It seems to know more generally about the world. It doesn't dodge questions as much, and it seems to be able to produce and explain code, at least Python, better than before. So I was frankly quite, I don't know about stunned. Some of it was pretty stunning, but I was very impressed by how much of an improvement is there. So that's exciting. And then one thing that I had one fun session where I challenged the reasoning power, because I saw several examples on OpenAI's website which were really quite breathtaking of reasoning, visual reasoning, and then solving some riddles and some stuff like that. So visual reasoning, logical reasoning. And so I gave I didn't want to offer a riddle that it might actually have already seen out in the wild. I think giving these systems famous riddles to solve is probably not a good idea if they happen to have read them or been trained on them. And it's actually surprisingly difficult to quickly think up a riddle. So I instead constructed a situation with sort of just to kind of catch you out by with a simple thing where you're making a false assumption. So anyway, here's the situation I presented to ChatGPT today with GPT4 as its model. The situation was, okay, a driver has stopped their car and gotten out and did not return to the vehicle until the next day. And then when they returned to the vehicle, they were not able to drive away. They had to call for roadside assistance. What happened? What is going on? What's the most reasonable thing to conclude about, or what are the most reasonable things to conclude about this situation? And so I asked, now I had a particular scenario. There are a lot of different scenarios, or several anyway, that could fit that, that scenario as I've described it. A lot of different things could have happened. And it was what I was curious to know was, what would GPT's reasoning be? And so when I asked it, and I was careful, but it's asked unprompted, I just gave it this situation. I said, what do you think happened? And it explained some of its reasoning. But it wasn't too bad, and it offered some points, and it did a good job. It reasoned that there were things about the environment to try to understand, things about the motives of the driver, the situation of the driver to understand, and then things about the condition of the vehicle, both the first day and the following day that were there to understand. But it didn't catch all of them. And then as we've seen, with better prompting, the results improved substantially. So when I prompted it to explain its reasoning, it did quite a bit better. It laid out, more thoroughly the possibilities and worked its way through them, eliminated some things, or at least laid out some possibilities that were a bit more thorough, all of that. And then as a final stage, because it still hadn't gotten the scenario that I described, or the one I had in mind, I said, okay, now after you do all of that, state all of the assumptions that you're making at each stage in your reasoning, and incorporate those into your explanation of your own reasoning. In other words, try to identify and explicitly draw out the assumptions that you're making about any of these things that you're talking about. And so getting it to interrogate or question its own assumptions improved it even further, and then it finally reached the conclusion that was the scenario that I had in mind, which is that the driver got out of the car and had to disappear, but left the car running, and the car ran out of gas. And then when he came back the next day, it had no fuel, and that's why he couldn't drive it away. He had to get roadside assistance. And
my response was that it left the headlights on.
So it had worked through a number of different possibilities, including the battery dying and so forth, and that this was the most common cause of a car that won't start and so forth. It also asked about, well, was it in a dangerous area? Was it winter time and so forth? And as a final stage, I forgot to mention, as the last stage, the last prompt update, the last modification to the prompt that I said was, before you start reasoning, ask me questions for clarification about anything that you aren't sure about. Anything that you think you're assuming, ask me to clarify your assumptions. And then it did. Before it started answering, it asked a few questions, and then it got it right, or at least it did identify the scenario I was imagining as one of the possible scenarios explaining the observations. Anyway, it was all fascinating. It was very, very impressive. But here's the takeaway lesson that I had from this, which is that there's great utility or usefulness in having good habits. You could call them hygiene. You could call them reasoning or logical or cognitive hygiene. You basically just have good habits about things to do. And I think those of us who are very highly educated and have a lot of training and a lot of experience in thinking in certain ways. So if you have scientific training and you're working in some academic capacity or intellectual capacity, you're basically running all of these hygiene loops on yourself continuously. You're checking and challenging and questioning your own assumptions. You're asking whether the things that you're observing are mapping to reality. You're walking through your logic over and over again. You're trying to, you're just exercising a whole bunch of good thinking habits. Now, what struck me as very odd with GPT-4 is that behind the scenes, because I don't know what's going on in the engine behind this thing, and what do I know? Dan, you are able to, and you guys are able to make inferences about that, but I don't know. I'm a layman. I'm a layperson. But I'm surprised, personally, that this isn't already being baked in before you get any response at all out of these systems. That was what surprised me, was that. If you were to ask me naively, I would have said, well, the easiest way to improve the quality of the reasoning of these systems is just to invisibly prompt them before they even interact with you. But clearly, prompting them further is doing more. You're getting some benefit and improvement in the performance. So I found that very surprising. Now, I don't know whether this is just like additional good hygiene, and there's already a whole stack on that is there that we don't see, and this just a bit more helps, or what's going on. But I found that really quite surprising and perhaps revealing. So anyway, take that observation for what it's worth. Maybe something, maybe nothing. And then the one final thought was that with this good hygiene, with this sort of reasoning and stating assumptions, and asking for clarifying questions before you answer, all of this made me suddenly realize right at the end of the conversation that there's no filter, there's no moment or period of internal quiet thought process or dialogue from GPT-4, at least not that I can tell. Now, again, you guys correct me if I'm wrong about this, but what it seems to me is that it just starts talking.
Yeah.
It's like, imagine if it, and again, I'm reasoning by analogy with human beings, but it would be as if you asked a question to a person, and then they just immediately opened their mouth and started blurting out their stream of consciousness rather than thinking before they speak. And of course, one of the most fundamental good habits of cognitive or intellectual hygiene is think before you speak. Don't open your mouth first. Get your thoughts in order, think things through, and then articulate your thinking. Well, it strikes me as pretty clear that GPT is not really doing that if it's only predicting the next token, and then you can see it's kind of, you can see the tokens emerging. You can see the words emerging, fragments of words that then become whole words, and so on. But what I wonder is, especially for now that it's got a larger context window, I mean, what about some recursion there? You ask a question and it gives itself a minute to think. It produces a whole response, feeds that back into its own prompt, runs all of the good hygiene on that, produces another prompt, does that whole recursive cycle 2 or 3 times, and then gets to a useful output. Now, I would imagine that recursion could improve the results substantially, and it would slow it down a little bit. But that's what people do. This is what humans do. Unless you're, the jerk at the bar who's just blabbermouthing without, any filter at all. And we make fun of that. We mock that in other people, right? So anyway, these were just things that I was struck by in my just, brief interaction with the system this morning. And it seems to me that there's some pretty low-hanging fruit for making what I imagine would be quite strong improvements in performance just, right out of the gate.
Yeah, I think that's right. I think that even with these post-processing steps, post-training steps, still GPT-4 is kind of like the raw material, right? And then you can do what you're suggesting, which people have observed that processes like that do increase the performance on reasoning tasks. Probably the improvement is less now with GPT-4 than it was with GPT-3. I think that as the models improve, the gains from this, at least in some benchmarks, may decrease. But for example, if I was Morgan Stanley or any knowledge working institution, I wouldn't just be running inputs through the model and then spitting it out. I mean, I would be spending millions of dollars a year with a back-end process that is churning through all the documents, synthesizing stuff, writing essays, having other models critique the essays, and like have this whole ecosystem of reasoning bots, and then surface like one paragraph to the VP, like, here's something we're missing, or here's a risk that you haven't been paying attention to. Why not, right? Like, how many stupid things are humans just not paying attention to because of lack of attention? It's not like they're deep, right? Like, do you think what went wrong with Silicon Valley Bank was like some deep thing that nobody could have noticed if they were just paying attention? No. Like, the world is mostly, sometimes there are deep problems that are really just difficult to see and figure out, but mostly it's just a lack of attention, competence, and relevant knowledge. I think we may be surprised how much leverage you can get over the current world by just having a lot of things pay fairly shallow reasoning attention to a lot of information.
I strongly suspect that will be one of perhaps it'll be an early stage, and crazy things will come after it. But I pretty strongly suspect that what the first taste of super intelligence will have that kind of quality to it. The sort of things that when, like, there have been throughout human history, and then in each of our personal experience, I'm sure, there are instances where something is very difficult to think of, but then seems obvious in retrospect. Like if only you'd been able to see something a certain way, or pay attention to it in the right way, or put the pieces together sooner, it would have been obvious. And I think that is precisely the way in which these systems will seem super intelligent. That things will be obvious to systems with unbounded attention that are not obvious to minds that have very, very, very limited attention and context windows and short-term memory like humans do. So I think that I strongly suspect that's, and we're going to be humbled by that. I guess my guess is that we're going to be humbled by how quickly that emerges. And there may be some truly deep and profound ideas that are very difficult for anyone or anything to think of. But that's not where I would be putting my chips on the table. I would be putting my chips on the table of, if you could pay enough attention and your memory's good enough, and you've got a lot of compute and you've been trained on a lot of stuff, everything's going to seem obvious to you.
Before you have to go, Adam, let's go back to these pictures and reveal what they are. So the left-hand picture, I don't know that it's the specifics data center that has the OpenAI supercomputer that Microsoft built over the last few years, because I don't know that that's public information, but this is a Microsoft data center. And we also don't know exactly what's in it, but from public statements from NVIDIA and Microsoft, we know there's tens of thousands of A100s. There's a recent report from JP Morgan, I think, claiming that there's 25,000 A100s in the supercomputer, which is about right, so I'm going to take that figure. Each A100 is sort of on the order of $20,000, but I assume they have some discount. Anyway, probably it's on the order of $200 to $300 million for whatever this supercomputer is. And it's interesting to compare that to the right hand, which is Oak Ridge, which many Americans will know. But so that's the K25 gaseous diffusion plant, finished in 1945. It cost $500 million. This was, well, when people thought that nuclear bombs might be possible, there was a lot of investigation, a lot of doubt, right? People thought, the obvious ways to do it seemed like they would just not work. And then people figured out that separating isotopes of uranium was the way to do it, but it seemed very laborious and you'd need hundreds of thousands of these things, and that seemed kind of insane. But here's a building which contains the gaseous diffusion devices that separate out the right isotope of uranium, and it was the biggest building in the world when it was built, and that was over the course of 4 years from start to finish. So, this is $500 million in 1945 money, I guess. So maybe it's a bad comparison. I didn't actually check whether it was inflation adjusted or whatever. But the point being that there are orders of magnitude above our head if people start to really care about this. So, interesting times. maybe it isn't right to think that the next model of GPT, like the next version, GPT-5, we may be reaching some sort of limits of scaling in terms of data set size, and you can't spend $2 billion every year on training models probably. So maybe it starts to level out at some point. It depends how transformative the capabilities get and how big the applications are. But it's sort of unclear what the trajectory is. It's not automatic that it will be 200 million this year, in 3 years 2 billion, and then 20 billion or whatever, right? But the example of the Manhattan Project shows you that things can really change, and investments and labor and effort in scientific directions can go more or less overnight from minimal to very dramatic. So this can happen.
Well, one question. I do have to go. Maybe we can return to it next time. But let me ask it now, just so I don't forget. But looking at this and the size of these facilities, my understanding is that these like the facility that's there, that supercomputer that Microsoft OpenAI built, that is mostly for the training of the model. And is that correct?
Yeah, it's probably also used for inference, but maybe inference is handled in a different data center. I don't know, but it's primarily for the training. That's right.
Hey, Bug. So my question would be, and maybe this we can return to us next time as a topic, is to understand the relationship between the compute resources required to train the model versus to actually run the model, and what any trade-offs or comparisons that might be the case there. Yeah, I think there's potentially some interesting things to think about there. And if you, what kind of model would you train if you had a $200 million a budget year to run it just for a single user, as opposed to running it for 10 million users? Would it be different, or would it still be? I mean, would there be any usefulness to it? Would you, in other words, if you had a huge amount of money from one customer, could you create a context window 10 times or 100 times or 1,000 times larger, and would that radically change a given model's performance? That's the kind of that relationship between the model size and the model running the model is something that I would like to understand a little bit better. Anyway, but I do have to run, so maybe that's something we could talk about next time, if that sounds
great. Okay, we'll leave it at that. Thanks everyone.